So you have seen some experiments over here. Now what we can do is we can start the other things that yeah we have seen a lot of experiments now on this. So now we can start studying further. Now see, this is a reaction which I was telling you, that is reaction of excess ammonia with chlorine. Dense white fumes of ammonium chloride are observed. But what is this? This is ammonium chloride. Directly the reaction doesn't take place like that. So you know what happens in this reaction? I'm going to write down the steps. Try to follow the steps. Ammonia first reacts with chlorine. Okay. And it gives us nitrogen, plus it will give us HCl. How do we know it is HCl? Excuse me. How do we know it is HCl and nitrogen? Because as I told you, ammonia is a reducing agent. So it undergo oxidation. Means what? It will give away its hydrogen. And therefore it is remain only a nitrogen. Okay. That is what it is. And then there's an arrow over here. So you can just place the arrow. Okay. And this is what we'll have to work it out. Now you have to balance this equation. Once you balance this equation, you will be able to. So this is 2 over here, this is 3 over here, and then this is over here, it will be 6. So it will be 6 over here, right? Now what is going to happen? That is excess. Therefore, again ammonia, some more ammonia, it is in excess, right? So some more ammonia is going to react with it will react with chlorine. Okay, so it's going to react with chlorine to give you ammonium chloride. Yes, and to give you ammonium chloride. So I'm going to write here ammonium chloride, right? And now we need to balance this equation. Basically, it is not that chlorine, it is going to be HCl, because we are doing the reaction. So, so ammonia reacts with this HCl to give you ammonium chloride, isn't it? That we know that. So, just put this over here. Okay, now this is 6, so try to balance it with 6. Multiply the whole equation by 6. Multiply the whole equation by 6. Okay, why? Because you need to add up now both the reactions. Now when you add up both the reactions, you will get over here you are going to get, see, add up both the equations. What you are going to get? Add up. Add up. So you'll get 8 ammonia over here, then 3 chlorine. What happens to this? What happens to this? This gets cancelled. This gets cancelled. With this also gets cancelled. These both are going to get cancelled over here, right? And you are going to get 3 Cl2, nitrogen, and 6 ammonia. This is how the whole reaction is going to come to end. So what is the observation you are going to write down? So this is a two-step reaction. Understood? The first step is the nitrogen gas and HCl. There is no observation for this. Second reaction, ammonium chloride. And when you add up, you get this is the total reaction. Therefore, you can say observation is dense white fumes of ammonium chloride are observed. Now, reaction of ammonia with excess of chlorine. This is also very simple. This gives you a trinitrogen chloride, right? Nitrogen trichloride, not trinitrogen chloride, because nitrogen is only 1 and chlorine are 3 atoms. Therefore, nitrogen trichloride is formed. And what is the observation? Yellow, oily, explosive, viscous liquid. Dense white fumes are formed when glass rod dipped in ammonia, and also there's a HCl over here that comes out to be, and therefore glass rod dipped in ammonia solution. If you bring it near this, what will happen? Dense white fumes. Therefore, these two are the observations over here. Now, test for ammonia has been given. It is a characteristic pungent, irritating odor when glass rod dipped in concentrated HCl brought. You just now saw that when ammonia is passed through Nessler's reagent, you have done that. What happens? First, it becomes a pale brown, and then further in excess, it becomes brown precipitate is obtained, right? So first, you will become pale brown, and then in excess of Nessler's reagent, sorry, uses of ammonia are there. So they are very simple uses of ammonia. Important is fertilizer, urea and ammonium sulfate, liquor ammonia. This is very important. This gives you as a give reason. Give reason is there, that is liquor cleansing agent, emulsifies, dissolves fats, and therefore it is used for cleansing window pans and all that. Then grease, it is used to remove oil and grease stains from clothes because of this only. Now this next one is also very important. Liquor ammonia is a refrigerant, that is highly volatile, has high latent rate of evaporation, easily liquefies under pressure. So it's a highly volatile, as you know. See, this what happens, liquor ammonia is evaporated, absorbs, see, when it evaporates, it absorbs large amount of heat energy, isn't it? And therefore it makes the surrounding cooler. That is how basically turning the water into ice, and therefore it is used as a refrigerant. So any two answers you have to write down. It is a highly volatile, it has a high latent heat of vaporization, and easily emulsifies, liquefies under pressure at low, that minus 33 degrees Celsius or 8 atmospheric pressure, it liquefies, isn't it? So these are the things. The rest, how to differentiate, distinguish, that we'll do it little later. So I think we should stop here. So make maximum use of these all things, because in the class also sometimes we cannot show you so many things. So try and view this. Thank you, children.